Hello and welcome back to another lesson on GCSE physics. Today the learning intention is to understand stopping distances. Now stopping distances, as the name suggests, is essentially the distance travelled by a car whilst it is stopping. Now the Do It Now task for today, I would like you to describe and explain the energy changes that occur when a car does an emergency stop. Pause the video, write down your answer please, and then I'll explain what the marks will be given to you for. So the task was to describe and explain the energy changes that occur when a car does an emergency stop. Now, whilst the car is moving, the energy is in a kinetic energy store. So we get 1 mark for saying that the energy is transferred from the kinetic energy store of the car. And then the second mark is for saying that it goes to the thermal energy store of the brakes. Now, some of the energy will go to the thermal energy store of the brakes, as I've specified there, but you could have also said it goes to the thermal energy store of the wheels of the car, or you could have said it goes to the thermal energy store of the surroundings. It doesn't matter as long as you give one of those examples. Now, because this was an explain question as well, we need to say why energy has gone from the kinetic energy store of the car to the thermal energy store of the brakes. And it is because of the force of friction. Now, when a force causes energy to be transferred, we say that work is done because of it. So the third mark is for saying because of work done by friction. Now, today's success criteria is to know what thinking and braking distance is. It is to list the factors that affect thinking and braking distance, and finally to explain why different factors affect either the thinking or the braking distance. First thing I'd like to do for me please is what things can affect how far a car will travel before it stops. How many things can you think of? So you've got your car driving along, what will affect how far it travels before it stops if the driver realises that they need to apply the brakes? Make a list for me now please, and then we'll talk about the things that I came up with and see if we've matched on any of the ideas. So the things that I thought of were if the weather is particularly bad. Now, bad weather you could give specific examples of if it's been raining heavily or if there's ice on the roads. They are definitely going to increase the distance that the car will travel before it stops. Likewise, if the driver is tired, then they might not press the brake as quickly or as hard as they would have done, and so they will travel further. If the driver is distracted, then of course they're not going to press the brake as quickly as they should have done. The condition of the tyres, if the tyres are in poor condition, then they won't be able to give as much friction, and so that would affect how far the car is going to travel before it stops. The fifth idea that I came up with is if the driver is under the influence of alcohol. Again, like the idea of the driver being tired and the driver being distracted, if the driver is drunk or under the influence of drugs, then what may happen then is that again they will not press the brake as quickly, and so they will travel a further distance. And then finally, the speed of the car. Naturally, it follows that if the car is travelling faster, then they are likely to travel further before they stop. Now, the stopping distance is actually made up of two separate things. It is made up of the thinking distance and the braking distance, and we've got an equation there highlighted in red that we need to learn, which is that the stopping distance is equal to the thinking distance plus the braking distance. Now, the thinking distance is the distance travelled during the driver's reaction time, so the time when they see a hazard and then realise that they need to apply the brake. And then the braking distance is the distance travelled once the driver has started applying the brakes to the moment the car actually stops. Now, there's some information just below. You don't need to learn this information at all, but it just illustrates how the thinking and braking distances differ depending on the speed of the vehicle. So you can see for a vehicle that's travelling at 20 miles per hour, then the total stopping distance is just 12 metres or 40 feet. Whereas if the driver is travelling at 70 miles per hour, then it's going to take 96 metres to come to a stop. So you can see that the faster you are going, clearly the bigger the stopping distance is going to be. Okay, we're now going to sort some factors out into whether they affect the thinking distance or the braking distance. The first one being icy roads. Well, if the roads are icy, then that isn't going to affect the distance travelled during the driver's reaction time, but it will affect the distance travelled once the driver has started to brake, because obviously if the roads are icy, then there is less friction and so they will travel further. Bad tyres also will affect the braking distance, because again, if the tyres are bad, then that means that there will be less friction and so the braking distance will be increased. If the driver is driving under the influence of drugs, that's not really going to affect the braking distance, because it won't affect the amount of friction between the wheels and the brakes, but it will definitely affect the thinking distance, because if the driver is under the influence of drugs, then their reaction time is going to be longer and so they will travel a bigger distance during that reaction time. Then the next one is the driver being tired. If the driver is tired, likewise their reaction time is going to be bigger and so they will travel a further distance in that reaction time. Then finally we've got fast speed. Now if the driver's going at a fast speed or a faster speed, then they will travel further in their reaction time, which means that the thinking distance will be increased. But the car will also have more kinetic energy that it needs to lose to come to a stop, so the braking distance will be increased as well. So fast speed can actually go into both of those columns because it will affect both the thinking distance and the braking distance. Okay, what I would like to do for me now, folks, is pause the video and have a go at these questions, and then we will go over the answers and see how you have done. So question 1. As part of a driving test in the UK, drivers are expected to perform an emergency stop. This means that they need to stop in as short a distance as possible without skidding. The table below shows some data for 3 of these emergency stops that have been performed in recent driving tests. And the table shows the speed that the car was going at in miles per hour, the size of the braking force in newtons, and the braking distance in metres. Part A says, describe how the braking distance varies with speed. Now you can see that as the speed goes up down the left hand side of that table, the braking distance goes up as well. So we'd get 1 mark for saying the faster the speed, the bigger the braking distance. But this isn't a 1 mark question, it's a 2 mark question, so we need to look a little bit more carefully at the data. The first mark, as we've said, is for saying as the speed increases, the braking distance increases. But look at the difference in braking distance between 20 and 40 miles per hour. It's gone from 6 metres to 24 metres. But as we go from 40 to 60 miles per hour, the braking distance goes up much more than it did do previously. So we'd actually say that the bigger the speed, the bigger the increase in the braking distance is, and that gets us the 2nd mark. Part B. What would need to happen to the braking force of a car travelling at 40 miles per hour to enable it to be brought to rest in 20 metres? Well, when the braking force is 10,000 newtons, it takes it 24 metres to come to rest. So to stop it in 20 metres, we would need that braking force to be bigger. So the answer is we would need a bigger force. Part C. Explain why the brakes become hot as the car slows down. So they've actually started the answer for us, which is nice. They've said the friction between the brakes and the wheels reduces the something energy of the vehicle. Well, the friction is obviously going to be reducing the kinetic energy of the vehicle, which is nice and straightforward. It then says this energy is transferred to the brakes, which then we can say so that the amount of energy in the thermal store of the brakes is increased, increasing the temperature of the brakes. I've probably not phrased that particularly well, but basically you'll get your marks there for saying that the temperature will go up because the amount of energy in the thermal store of the brakes will increase. 2A. State the meaning of thinking distance. Well, thinking distance is the distance travelled during the driver's reaction time. Part B. State 2 factors that can increase the thinking distance. Well, there's definitely more than 2 factors, so any 2 of the following will be fine. You could have driving at fast speed, taking drugs, drinking alcohol, and of course finally the driver being tired. Part C. State 2 factors that can increase the braking distance. Again, there's definitely more than 2 factors that we can have, but we will get marks for saying driving at fast speed, the tyres being poor quality or being worn down, Likewise, the brakes being of poor quality or being worn down. And then finally, a specific example of bad weather, such as the roads being icy or the roads being wet. Question 3a. Explain why the factors that affect the thinking distance of a vehicle at a particular speed are all connected with the driver and not the vehicle or the state of the road. Well, the reason for that is that the thinking distance is just the distance travelled during the driver's reaction time. That gets you 1 mark. The second mark is for saying, and so therefore it only depends on the driver's reaction time. Part B. The factors that affect the braking distance at a particular speed are usually all connected with the vehicle or the road, but suggest how the condition of the driver could also affect the braking distance. Well, essentially, if the driver doesn't press the brake hard enough, then that is going to affect the braking distance. So, the braking distance given assumes that the brakes are fully pressed and that the car doesn't skid. If the driver is not alert, then the driver may not press the brake hard enough.